Okay, girls, this is 1I, simultaneous equations using substitution. So what happens is I get two equations. I'm just going to graph them quickly. I'm going to use this kind of intercept method and say the y-intercept is 8, the x-intercept is 8, and then I'm going to grab my ruler and I'm going to do this. If I had a really good piece of graph paper, this would turn out a lot better. And this is in y equals mx plus b form. So I'm going to say, okay, the y-intercept is, it might be a different color, 4, 1, 2, 3, 4. Then I'm going to go up 3 over 1. It's looking like they hit right there, isn't it? And so the idea of simultaneous equations is that I find the point where they intersect each other. So, you know, I find this point. Now, we're using substitution in this exercise, not graphing. I just wanted to show you that. What the real problem using substitution is to say, well, you know, I want these two x's and these two y's to be exactly the same. So what I can do is I can take this value here, it's equal to y, and I can shove it in that y. Okay, so I take the y from one equation, or the x, but in this case the y, and I replace the other equation with that y. So I have x plus, and then I write down my substitution. That went to there, equals 8. So I'm using this equation, but subbing in that y. So I get 4x plus 4 equals 8. So I get 4x equals 4 and x equals 1. Hooray! That's what I got right here. I think it was. But I need a point now. And so 1 is just the x coordinate of the point. I got to place that 1 back into either one of these equations. I'm going to pick the second one to figure out what the y value of the point is where they intersect. I think you know the value already, but it's 3 times 1 plus 4, or 7. So that was pretty easy. I used substitution. All right, let's do a little bit different one. Here's the second one. I have this equation and that equation. I always take the equation where, you know, I have a variable isolated, or sometimes you have to isolate the variable, but here it is. And I'm going to take that, it's equal to x. So I'm going to put it where the x is in the other equation. That's why it's called substitution. So I go 2 bracket y minus 3. Minus 3y. It's up here, right? That replaced that. So there's the minus 3y equals negative 8. Okay, so I need to expand this to solve. So I get 2y minus 6 minus 3y equals negative 8. So negative y equals, I'm taking that 6 over there, I'm adding it over there, so I get negative 2. And if negative y is negative 2, then y is 2. So I figured out the y. Now I'm going to use this equation, and I'm going to put that back in. So I have this subbing back in, substitution. X equals 2 minus 3. So x equals negative 1. So I've got a point. I've got the point negative 1 comma 2. And that's where these two lines are going to intersect. You could type them into Desmos, and you could see if they intersect there. And you'd see that they would. Okay, so this is 1I. And you need to do 3, and then for 4 and 5, you need to do every second. There's a bunch of parts. And then 6 and 7 are the problem-solving questions.